So, children, we have already seen relative lowering of vapor pressure. P1 standard is X2. Delta P upon P1 standard equals to X2. X2 is the mole fraction of solute. X2 is what? Mole fraction of solute. Means if 1 mole of solution you are taking, 1 mole of solution, then how much is X2 and how much is X1? That is known as the mole fraction. Children, while calculating mole, we divide given mass by molar mass of any substance. For example, if someone has given me take calcium, which is having molar mass as 40 gram. Now what does it means? It means 1 mole of calcium means 6.022 into 10 the power 23 particles of calcium. Their weight will be 40 gram. Correct? It is known as the molar mass. Molar mass of calcium. Means mass of 1 mole of calcium. Molar mass of calcium is 40 gram. If I am taking these many particles, this is a very big number, crores and crores of the atoms of calcium. If you are taking together, then for this much number of the particles of calcium, weight is going to be 40 gram. Talk in a reverse way. If I am taking 40 gram of the calcium, then I am taking this many number of the calcium atoms. And these many number of calcium atoms means 1 mole of atoms. Mole is a specific word for this number. Mass of 1 mole of substance is known as molar mass. Again, mass of 1 mole of substance is known as its molar mass. Now children, if someone is giving you 80 gram of calcium, how much calcium? 80 gram. And he asks you, suppose he is asking you, tell me how many moles are present. 40 gram means 1 mole. So 80 gram you will divide by 40 and you will say that this is 2 mole. Exactly the same thing I have written. Given mass divided by molar mass. Given mass divided by molar mass. Now children, this concept we are going to use throughout this chapter. Suppose mass of the solute is W2, its molar mass is M2. So number of moles, number of the particles, say N2, is given by W2 upon M2. Now here I will revise the concept of mole fraction. Mole fraction means X2 is N2 upon N1 plus N2. If suppose, students, I am taking 4 moles of solute and say 46 moles of solvent. Always solvent is large in amount. This solution is now containing 4 moles of solute and 46 moles of the solvent. Total weight, total number of moles will be 50 moles. Yes. Out of this 50 mole, if suppose this 4 and 46, if I am adding together, it becomes what? 50 mole. Of course, this will become a mixture. This will, everything will get mixed. If I am taking out 1 mole of this solution, then 1 mole of solution is containing how much? How many moles of solute and how many moles of solvent? This every 1 mole is containing how many moles of solute and how many moles of solvent. That is known as the mole fraction. While calculating, I will just write 4 moles of solute divided by 4 plus 46 means total 50. Mole fraction I am calculating, so I will write N here, X2 value. But now you have to divide this number, which comes out to be 0.08. How I calculated, I will show you. If I divide throughout by 2, numerator and denominator, I am getting 8 by 100. That comes out to 0.08. Children's, 0.08 is what? Solute, and rest of the 0.92%, 0.92 part will be solvent. How I got 0.92? Because total 0.08 plus solvent was 1. So solvent now is going to be 1 minus 0.08, 0.92. So children, hope here the concept of mole fraction is clear with you. Whenever you are calculating mole fraction of solute, you write how many moles of solute are present divided by total number of moles of solute and solvent. Here I did the same thing. Moles of solute were 4. Now total number of moles of 4 plus X2 is 4 upon 46 plus 4. Total is 50. I calculated it. I got the number of the solute particles. This is the mole fraction. Means in this solution, if you take any from any side, now not is mixed, you take 1 mole. So every 1 mole will have 0.08 part of the solute. Now we have to make it entire 1. So 1 minus 0.08, that comes out to be 0.92. So this entire 0.92, this 0.92 parts will be of solvent. Since we are calculating for 1 mole, hence we use the word fraction. If you calculate it for 100 mole, let's make it more clear. If I am calculating for 100 mole, then every 100 mole will contain 8 moles of solute and 92 moles of the solvent. Here we are talking in the terms of percentage. Every 100. Out of every 100 moles of this solution, out of every 100 moles of this solution, 92 moles will be solvent and 8 moles will be of solute. That is when we talk in terms of percentage. Means out of 100 moles. But here we are discussing for 1 mole. 1 mole of this solution is containing what fraction of solute and what fraction of solvent. We use the word fraction when we talk for 1 mole. So children, here I have written these things. This was the example to explain you. Now we will come back to our base actual formula. X2 is N2 upon N1 plus N2. Children, you might have noticed that this solute particle N2 is what? Moles of solute. N1 is what? Moles of solvent. N2 is always in a very small amount. Very small amount. So negligible. X2 equals to N2 upon N1. You say that N2 is very small. Or put this way. N2 is very small. Since it is very small, then why we are neglecting only at this place? Why not here? Question comes. Sometimes students they ask, sir, we are rejecting it here. Why not here? From here, if you remove, it is entirely finished. Nothing will left out over there. Actually, we are not rejecting it. What we are telling, if suppose someone is giving you 1,000 or say 10,000 plus 50 paisa. That 50 paisa is what? Negligible. So 10,000 plus that 50 paisa is approximately 10,000 only. Henceforth, we are keeping it as N1. Because 10,000 plus 50 paisa is approximately same. Your answer will remain same, approximately same, when you are putting 10,000. Hence, for that purpose, for ease of calculation purpose, we are neglecting this N2 value and keeping here only N1. N1 is what? Moles of the solvent. Now children, already you have seen that number of moles are calculated by writing given mass by molar mass. Number of moles we can find by writing W upon M. W is what? Given mass. M is what? Molar mass. So children, N2 I can say it is W2 upon M2. And N1 I can say W1 upon M1. Now children, X2 is going to be N2 upon N1, N2 upon N1. So X2 is going to be, you write N2 as W2 upon M2 upon W1 upon M1. So X2 is now going to be W2 upon M2 into. This moves on the upper side and it will get inverted, and X2 is now here W2 M1, M2 and W1. This is the thing. Now X2 we have calculated. Children, let's put this value in this formula. Relative lowering of vapor pressure is divided by vapor pressure of the pure solvent equals to X2, and that X2, now I can write W2 M1 and W1 M2. W1 M2. So out of these, any of the information if missing and others are given, then we can calculate it. So children, let's start with the numericals. So children, let's start with the numericals. See in the question what they have given. They have given that the vapor pressure of a solution containing this much of the solute in this much of the water at this temperature is this much. Calculate the molar mass of the solute given that vapor pressure of the water at this temperature is this much. Children, in this question, what they have given, let's try to understand it again. They have given that if I am taking pure water and temperature I am maintaining at 298 Kelvin, then vapor pressure will be, vapor pressure of pure component water now is going to be 28.065 millimeter of mercury. It is a unit for measuring the vapor pressure. Now children, P1 standard is 28.065 millimeter of mercury. And here I have taken only water. Children, if I add some solute particles to it, means water is there, same temperature, and now I am adding some solute particles. What do you think? Vapor pressure will increase or decrease? Definitely it will decrease, because the particles which are here will block the path. So the particles in vapor form will be lesser in number and this vapor pressure will be lower. This vapor pressure they have informed you is 27.371 millimeter of mercury. Millimeter of mercury is actually a unit for measuring the pressure. In this case, we are measuring vapor pressure. So P1, now this is vapor pressure of a solution. So we will change our symbol and we will write only P. Childrens, you can easily notice over here that there is a change. A value which was approx 28 now has turned somewhere 27. There is a clear lowering of vapor pressure. There is a clear lowering of vapor pressure. Now children, here we were having large number of the particles in vapor form, so higher vapor pressure, and here the number of particles reduced, so lower vapor pressure. Now children, we are writing delta P upon P1 standard equals to W2 M1 W1 M2. Delta P already we have calculated, other values are known to us, only M2 is under the question mark. So what I will do, I am taking M2 to this side, it is in the denominator, so it will come in the numerator. So it comes here M2. Other values will remain as it is without any change. Only M2 has come to this side. From here it has come here. This entire value will go on the other side and I will write as P1 standard upon delta P. Now children, we will put the values. W2 value is 13 into 10 the power minus 3 into M1, which is 18 into 10 the power minus 3, W1 0.1 into P1 standard. Already P1 standard was given to us 28.065, so I am writing it here 28.065, and delta P value we have already calculated 0.694. Both the values are in millimeter of mercury. Both of them will cancel each other, so there is no need to change any unit. Both of them are in the millimeter of mercury. Now children, while doing our calculation, first stage, we will arrange the powers. I am writing 13 into 18 into 28.065 divided by this number 0.694 into 10 the power minus 1. This 0.1 I am writing as 10 the power minus 1. Here 10 the power minus 3 and 10 the power minus 3 will become 10 the power minus 6. Children, we have written here m2 equals to these values. Now 10 ka powers, if I adjust, 10 the power minus 1 will go in the numerator. So it will become 10 the power minus 6 into 10 the power 1. Now powers, if you adjust, children, minus 6 and 1 will finally become minus 5. So leave now that apart. Only for this much we need to go through the log table, because children, in the board exams you are not allowed to use the calci. You will be given log table which you have to use. Children, here log 13, I have written every value which is in the numerator and multiplied. I am taking log and I will add it. Log of 13 I have written as 1.111239. Then log of 18 I have taken, log of 28 I have taken. I added them together. Thereafter, this denominator 0.694, I took the log of 0.694. This log value is bar 1.8414. Since this was in the numerator and this is in the denominator, so I subtracted it. We got this answer. And for this I am taking anti-log. And my anti-log value was 9.84. So I have 9.842 into 10 the power 3. And this 10 the power minus 5 was still there. So now I will write even that. 10 the power minus 5. 9.842 into 10 the power minus 2, because minus 3 and minus 5, these are the 10 ka power. So we will adjust it. I will write now 98.42 into 10 the power minus 3. This is all the calculation you have done in kg. So this much is the molar mass in kg. This is the kg per mole. This much kg per mole.